Hello all and welcome back. So in this video, let's continue our discussion and now understand with space complexity. So till now, we have understood about time complexity a lot well in deep. We have actually find out the time complexity of many algorithm which we have studied, the worst case, the best case. I've given you an assignment as well in which common codes which we write, you will be finding the accuracy, time complexity of that as well. Coming to space complexity, the idea behind space complexity is again the same, that I want to calculate the space required as a function of my input size. Again, in this particular understanding also, we will not be talking in terms of exact space because that can actually be different with respect to which OS you are working on, which language you are using, and other factors. But I can still quantify that if, let's say, I'm given an input, what exactly will the space of with respect to that input I will be using, and that is what I'm interested in finding out. Now, space complexity is not covered a lot and not even asked, but I still want to make sure that I explain you this as well in very much deep. The reason is twofold. First is that yes, it is asked many times in in interviews as well as in online assessments. Second is that being a good software developer, you should have an idea about space complexity as well. Like it helps you to actually make a lot better softwares, okay, which are optimized, and also help you to understand that different coding practices, right? When we are actually optimizing on something, let's say if this algorithm uses a less space, what benefit that will have, how it will help you to even avoid bottlenecks as well. Okay, so let's get started. Now I will be explaining you space complexity with a very easy example. You can just think of your operating system. Like let's say you will be watching this video also in some either your Android phone or your laptop or somewhere, right? So first let us see what space complexity comprises of. So space complexity, one second, yeah. Space complexity is actually the space required for input space plus the auxiliary space, right? Great. So now let me actually explain them one by one to you. First thing is the definition. So required as a function of input size, something which you have already understood with respect to time a lot deep, I guess. Now coming to space, okay, the very first thing is the input space. Now what do I mean by input space is, let's say you have written an algorithm to sort an array, right? So you are sorting an array, bubble sort, insertion sort. You will be, for that particular algorithm, taking in some input, right? So I will be giving you a list, or I will be giving you something, let's say, so we are going to study like tomorrow, I can give you a linked list as well to sort. So that should be fine. You will be taking that thing into input, right? So that is some space we actually have to actually consider. It is not something which you can take for free, because if you have written an algorithm, of course you're going to take in that space, right? You're going to take in that input. You cannot say that, okay, hey, I'm not taking any input. The intuitive example of this, what I can give you is, you can consider your operating system, okay? Let's say if you have a laptop which is having 1 TB. Now normally when you buy a laptop, in from that 1 TB, around 980 GB I think comes useful, and then in that as well there is around 100 GB or something, let's say, used by your OS, right? So Windows, Mac, any Linux even. Let's say 50 as a very conservative measure, okay? Maybe less than that, that is not the point. Now this 50 GB, right? 50 GB, not TB, my bad, yeah. So this 50 GB, right? This is something which your operating system is taking, and let's assume that you are just using an operating system only. Now you cannot say na ki I will be saving this space, I will not install anything. Well then how are you going to use it? In a very parallel manner, if you have written an algorithm to sort an array, how are you going to sort if you're not taking the input? Okay, so that is not something which you will be optimizing on. No, you cannot. Like you will be making sure you take the input. And always remember, many people think that space complexity is just auxiliary space, something which we are going to discuss in just a minute. It is not just the auxiliary space, it is the input space as well. The hard drive in your PC is actually also having the space of operating system. That is required, you cannot avoid that, but that doesn't mean that you will not count it. Okay, so I hope this intuitive example is a lot clear. Input space is considered. So if you have written an array to sort, that sorting will also consider the input which you are taking. Okay, great. So that's the very first thing. Second thing is the auxiliary space. Okay, now coming to auxiliary space, this is actually the extra space which you are using in your algorithm. Now we saw that in algorithms such as bubble sort, insertion sort, we were actually not using any of this auxiliary space, right? Bubble sort, insertion sort. Now, many of you might think that Mayank, we were using some space, like I was defining different variables, right? So one second, yeah, some error should be fine, yeah. So you will say that, hey Mayank, we are defining this n, right? So how are you saying that we are not using space? Well, the reason for that is this n which you are defining, right? That is again a constant space that is very less in consideration with, I would say, your overall space which you are using. The way you can think of it is like if you're creating a new folder in your OS, we don't consider that as a space, right? That anyway we are creating, it doesn't have any significance. In a very similar way, these constants which you create, right? You are going to create them, doesn't matter if the input size is just 1, 10, 100, billion. And with respect to that, this space will just be insignificant. Okay. So again, you have to understand one thing. We don't consider, let me write this as well. Okay, one second. Yeah. So we don't consider variables created as an extra space. Now here I just mean by variables, okay, like these small so variables which you are creating, let's say I, j, k, middle, all these anyway you are going to create, right? And they are insignificant. They are not dependent on the input size. If you are tomorrow getting an array of 100 or let's say 1000, you are going to create the same variables, plus there are some constant space, right? Let's say in Python, I know that around 28 byte is something which is initially just given to a variable. In C++, normally 4 byte is there for integer, and it is different based on the overall type. Now, with that understanding, you have to make sure, just like in time complexity, anything which you are considering extra in auxiliary space, that should depend on your input size. Now, a very good example of that algorithm, which actually gets affected by this, is your merge. If you remember, we use the merge algorithm, right? So where we merge two sorted arrays. Now, the way we did it in merge sort as well as a separate question was, we actually defined a new array which was having all the elements of original size. So the size of that array, size of that answer or extra array where we were adding the sorted elements, was dependent on my input size. So if tomorrow, let's say I'm just saying that sorted array, okay, this was actually dependent on your input size, dependent on input size. And now, because this is dependent, this is something actually which we care about. Like this is actually going to add to your auxiliary space, the space complexity, right? In bubble sort and insertion sort, for that particular reason, the space required is actually O1, it's constant. Whereas in merge sort, you can think space required is On, because you are going to actually create an extra array which will be having the space or the size of your input array equal to your input array, right? So that's the reason we take that in auxiliary space and not those small variables. Okay, great. So I hope this is clear as well, everyone. These are the two things which we will be considering. There is one more point which I would like to explain you. Okay, one more point. And always remember that auxiliary space does finally become something which we have to worry about. This is giving us major tension. Input space is again not in our hands, right? We cannot control the input space. The next thing which I want to explain you to is that at any given point when we talk about space, right? So let's say if this is the space which you are using and this is the time. Again, we are just consider or have an effect with the maximum space which you are using at a time. Okay, so let's say you are using some space and that peaked at this particular point. Then for your particular algorithm, you are going to say that this is your space complexity, right? How can I explain you this intuitively is that, let's say you buy a new phone. Okay, in that phone you first install something. Okay, let's say 8 GB is your size of your phone, right? 8 GB we can just assume. Let's say you install something for 2 GB, then you install something for 2 GB more, but then you delete both of them. Delete 4 GB, right? Then you install something of 6 GB. Now in this, finally, if you will see, I can say that this is plus, plus, this is negative, this is plus. The thing which I want you to understand is that you are not going to say that your overall space complexity in this is 10 GB by adding all these plus 1, right? The reason is that if you have to repeat these steps, you will be requiring just 6 GB of space, right? Because that is where your space peaked. In your hard drive, in your computer also, if you are adding some movies and let's say after watching, if you're deleting them, you don't count them in your overall memory occupied, right? You just say that, okay, at this point, let's say some 100 GB is occupied out of 200 GB. So that is what your space overall complexity is. If you added something and you have removed something, that doesn't count, right? That is not something which you're gonna consider, because we always make sure that we are just considering the peak space which is taken, peak space, and that is something which we even do, right? If in our PC we added something, let's say in your PC up till now you must have added maybe if let's say it's a 1 TB PC, you might have added 3-4 TB of data and deleted it over time, but then again it never peaked above 1 TB. That is what your overall space required of space complexity is for your all the actions in your PC. Okay, so always remember this, that we need to always worry about the maximum space which is required during the full algorithm run. We don't worry about the space which wanna get taken initially, intermediately, the space which is taken intermediately and then freed up, right? On that note, let me just show you an example as well. So just let me show you, yeah, great. On that note, let's say if I have n is equals to say some 10,000 and I write this loop while I less than equals to n, okay? And what I'm doing is I'm just creating this variable, a is equals to 5, a plus equals to 1. Then in this particular process, we are still using maximum space, which is going to be 28, I guess, is allotted in Python. In C++, that is 4 bytes for a particular integer. The reason is that this variable has a scope. It gets created inside and then get destroyed. So I'm not going to say that, hey, towards the end I will be using 28,000 of this 280,000 rather, not it was 10,000. So I'm not going to say that I'm going to use 280,000 space, 280,000 bytes. No, because this get created and this gets destroyed. So the overall peak will actually be going to be something like this only. Second, yeah, it's going to be 4 bytes. Okay. So that is what my space complexity, like, of course, it's a single variable, but yeah, that is what I would say that my space complexity is going to be if I'm considering this as a variable. I'm not going to say that it is 280,000. The reason is that it gets created, it gets destroyed. So at any particular point, it is not using more than 28 bytes in my PC. If you're not able to remember what 28 bytes is, let me just quickly show you here, or let me create a new file. So space complexity. Here I'm using the Jupyter notebook, should be fine. I will be sharing these to you. Please, this can be also open in Visual Studio Code, so should be fine, right? So import sys. This is something which you have already studied about in basics of Python. Let's say if I make a is equals to 4, then a, it's 28 around, right? Different based on compiler, based on language, but yeah, I hope you get the overall idea. Okay, so we are just basically making sure that we are considering the peak. Now, this is how you have to calculate the space complexity, and on that matter, I am pretty sure that for the algorithms, the iterative algorithm which we have done, you understand that they have a O1 space complexity if you are not making any new list or array or any other data structure based on the input. Okay, so yeah, that's the overall idea behind the space complexity. Please make sure that you understand and always remember that these two are the major things which are considered: input space and auxiliary space. And also remember this with the example, the intuitive example which I've given you, how just the peak is considered. Okay, how I am just actually worried about the auxiliary space majorly because input is not in my hand. But yes, again, that is something which I'm gonna give to the final output. So if, for example, just a last example, if let's say tomorrow I have a laptop, a window laptop, I'm gonna say that, hey, out of 1 TB, around 200 GB it uses for its process and some 10 GB I am using for my processes. So 210 GB is the space complexity. Right, so you have to consider the Windows part as well. That's the overall idea. Okay, cool then everyone. I hope this is clear. Now let's meet in the next video where we're gonna learn more about space complexity and also gonna solve it for few algorithm which we have done. Thank you.